all of us who are present. Oh. I will say so. It's just a remark off of my script because I'm a bit nervous. It's my first time presenting in such kind of big crowd, so please be patient with me if I'm sometimes stumbling or being a bit awkward or something like that. So I expect some understanding. Thank you very much. So today we're going to talk about lots of interesting stuff. Some of them you may already know because you're specialists, professionals. Our first speaker is going to be Alex Shershebnev. He's going to talk about supercharging DevOps with MCP. Up next, just a second. Up next, we're gonna, I'm just gonna go through the agenda for the evening so you would understand what's going on. Then we're gonna have a quick lightning talk by Evan Weinberg, the founder and CTO of Engine. Then you can get a 15-minute break to grab some snacks. Just people who would like to share some knowledge with you, gather up a community, which leads me to the next slide. Okay, not this one. But I still would like to mention the organizers who also are our dearest friends and helped us to make this happen. It's, again, Zenes and its evolution. So I've been asked about this question by a few people who actually came to me tonight as well. So what is the goal of the community of DevOps and AI Latvia? And the right answer is not just a goal, it's goals. So we're trying like we see the potential of you guys gathering and being all together, sharing your ideas and knowledge, which leads us to the idea of actually growing community and sharing knowledge, specifically in the Baltic states, essentially because, well, we are small countries and we would like to expand networking, expand stuff that we all know. And this would, of course, make happier DevOps specialists and better AI practitioners, better ethics. And we believe that the impact of gathering such a community would make us more effective, efficient, sustainable, and of course, it will lead to the more personal growth. And of course, if you'd like to connect with us, we have multiple channels. We use mostly hashtags of AI, Agile, DevOps, but we also have a general one. It's called General. You can also find us on LinkedIn. Our Facebook page is DevOps LV. So yeah, it's a bit like two different names, but I'm sure, guys, you'll figure it out. We also have Meetup that most of you have used and registered in through. And we also have our homepage, DevOps.lv. So you can always go there and check it out. So additionally, if you would like to, maybe, I don't know, maybe you feel like you would like to get out of your shelf and share something you know or something you're passionate about, you can always visit our homepage, leave the form, and be our speaker. And obviously, we will be very happy to see you and host you and make you as comfortable as possible. If by any chance, I'm not judging, of course, but if you're stage fright and you don't know how to speak, you can always contribute in 3 different ways. You can be 1 year general partner, 1 event general sponsor, and just 1 event sponsor. So don't be shy, just text us, email us.
Let me set this thing up because I have a lot of things here. And these need to go not here, but over here. All right, let's see, this one also works. Okay, great. Hello, everyone. Thank you for the introduction. And yeah, I will be talking today about MCP and how you can use it to sort of supercharge your everyday processes, and hopefully without opening the security hole, because AI and coding and DevOps is kind of new field, and there are still a lot of flashy news happening pretty much every week, where people are saying that AI, some MCP was hacked or some tool was hacked and so on. And hopefully, by the end of this talk, you get a better understanding on how you can protect yourself from those things and how to be conscious about using AI in your everyday life. Now, a few fun facts about me. So I've been in IT more than 10 years now, mostly in the different fields of AI, so computer vision, recommender systems, NLP, and so on. I've also been machine learning and DevOps engineer, doing backend, pretty much any field. I've been building Zencoder, my company, from the day zero. For the last year, I've been mostly working as DevRel, which resulted in quite a lot of flights. And this is my event number 43. And I also have 4 cats, which are waiting for me back home in Portugal. All right, and then another fun fact about actually the Slack community. I noticed that today there was 666 people, which is, I think, fitting because we are almost at the Halloween. So yeah, I guess a good, or maybe not good, I know, coincidence. Right, but yeah, let's finally get to MCP. And MCP is something that everybody has been talking about for the last year. Who actually here already uses MCP? Can I get a show of hands? Okay, so roughly maybe 25%. Okay. And more general question, how many of you use AI for coding for your work? Okay, a bit more. All right. Okay, cool. Well, yeah, to understand and to talk about MCP and why we need it, we need to sort of make a step back first and talk about AI or LLMs specifically, because they are sort of the main tool behind all the coding assistants, which hopefully most of you use or maybe will start using in the future. And LLMs, by their nature, are usually trained to predict the next most probable token or symbol, right? Sometimes it can lead to mistakes. So they're basically good at detecting patterns, but they don't understand what is behind those patterns, right? So basically, they can generate for you your for loop, but they usually might miss, what is there behind those patterns. But well, we all know how AI is with hands, so it's not surprising, right? But in general, those issues can be reformulated into LLM lacking or missing grounding in the physical world. And what that means is the model itself, the LLM, it just sits somewhere in the cloud, right? It doesn't have any access to internet, for example, doesn't have access to your local system, to your local computer. And if you ask it something simple, right? So like, what's the response time for Google? It definitely can help you on its own, right? So basically, one LLM won't be able to answer you, or especially if you are using some internal framework, if you have some in-house system, it will basically fail to utilize knowledge just because it never seen it, it don't have access to your systems and so on. So it can't really give you sort of contextualized answers. It just can maybe give you some advice on more general commands, like again with the example with response time. Usually, if you ask ChatGPT for Claude for similar answer, for similar question. It will give you some commands, which you might then run on your own, but obviously it's not what we would want from AI, right? We would want it to be able to help us without us intervening. And because of that, we can sort of rephrase this lack of grounding in the physical world into LLMs can collect extra context. And this extra context, again, can be pretty much anything, right? So getting response time, like the number of milliseconds, is essentially context for LLM. The same goes for your internal systems. So let's say some schema from Postgres. It is essentially context for LLM to be able to answer your questions more precisely. Well, the solution, right? So we can, I guess, give LLM access to tools, give it access to, I know, pushing code to production. So because what could go wrong, right? And yeah, I'm not saying that last week's AWS blackout was caused by AI, but who knows? And then, of course, we can also give it access to databases, maybe not write access because otherwise something bad could happen. But still, it is something that we could potentially allow LLMs to do. Well, hopefully not this, but yeah. Now, jokes aside, the main protocol nowadays to use tools or to give access to tools for LLM is MCP. MCP stands for Model Context Protocol, and there are also other different ways to give LLM access to tools. So there is, like, for example, LangChain or LangGraph, which also have its own protocol. But MCP became de facto standard, and MCP was introduced by Anthropic last year in December, so almost a year ago. And since then, it was adopted pretty much by anyone, right? So even OpenAI now uses MCP. And OpenAI is the main rival of Anthropic. So you can sort of see how big this protocol became, even though it was introduced just a year ago. And MCP essentially is a way for LLMs to get, in a standardized form, any context which it needs to give you more contextualized answers. It consists of two main things. So first one, of course, is MCP host. So MCP host is essentially your LLM. It can be your coding assistant. It can be some Claude desktop and so on. So basically, any tool which allows you to use LLM. And MCP host or MCP client is essentially responsible for choosing which tool it needs to use to get context relevant to your answer. And then there is MCP server. So basically, it's a counterpart. And MCP server is responsible for two main things. First, it sort of advertises its capabilities, right? So it basically gives to the MCP client the list of tools MCP server can execute, descriptions, names, parameters, and so on. And MCP server is responsible for actually running those tools, right? So those tools can access local resources, can access remote resources. So for example, it could be access to your local file system, or it can be access to Jira. So essentially, anything you can program, you can convert to MCP tool. And I will show actually how to do this in a second. But before that, tools actually not the only feature of MCP. There are like 5 main features. Let me move out of the screen here. So there are 5 main features, although we will be focusing on tools mostly. The rest are sort of less known and less used. They are still there, and they all are essentially used to source the context to LLM in different form or different way. And you can check them out on your own if you are interested. But the mostly used feature of MCP, or mostly known feature of MCP, is tools, and the main topic of today's talk as well. Now, here's an example. As I mentioned, so basically every tool has a description, essentially what it is used for. It has a name, it has input schema, if there are any input parameters needed. So in this case, this is a tool for creating branch in GitHub repository. It has a few input parameters. 3 of them are required. And this is essentially what is injected into the prompt, which then is passed on to LLM. And then LLM, based on description, based on your user query, it can decide if it needs to use specific tool, if it needs to perform some action, and then it decides which action, which tool to use to perform this action, to collect the context, and so on. And here's how the whole flow would look like if you are from you asking the question all the way to you getting an answer. So first, as I mentioned, MCP server is responsible for advertising its capabilities. And this is sort of like a handshake between MCP client and the MCP server. So whenever we start the connection, the client asks the server for the capabilities, and then the server responds with a sort of list of those tools which it can execute. Then, whenever the user asks for something and the LLM decides that it needs some external data, right? So in this case, it might perform an action to ping the website. It can request the MCP capability from the server. It can request the MCP server with a specific tool, with specific parameter inputs, and get, hopefully, the proper answer, right? So basically, the server will then execute, in this case, ping command, give back the milliseconds to LLM, and then LLM will be able to answer you based on more contextualized answers, essentially. And there are quite a lot of already existing MCPs. So this list over here is probably not in 1% of the available MCP servers. And as you can see, they all are in all sorts of different areas, right? So there are, of course, things like Grafana or ClickHouse, which, Cloudflare, which are kind of, IT related. But then there is also things like Exa, which is a search engine. So essentially, again, as I mentioned, anything you can program, anything you can access through code, you can convert to MCP server. And yeah, over here, the links here are just a few examples of MCP registries, there are now already quite a lot of registries, and there is actually even registry for registries. So yeah, basically over there, you can find all the different MCPs, which you might find useful in your everyday work. And here's a few examples of servers which are, I guess, closer to our work, close to heart, right? So there is MCP to access Postgres, for example. There is MCP to access Grafana. So you can ask LLM to check the metrics. You can ask LLM to check for issues, for logs, whatever. Same goes with Sentry. You can ask LLM to access issues there and maybe then hopefully solve it for you. Playwright is, not to be confused with Playwright framework. Playwright MCP allows LLM to use browser. So basically, you can ask it to go to some website, click around, fill in the forms, and then write a test for this, for example. But of course, if you are, if you find a case which is not covered by existing MCP, you might also create your own MCP as well. And there are quite a lot of different SDKs for that. I think there is actually now even more. But as you can see, they cover the most common languages. So you can create your own MCP server in any language you are familiar with. And it is generally quite simple to do so. So here's an example. This one is in Python. So over here, I'm just importing the library over here and just creating an MCP server. And that's essentially what is needed to convert this code. To convert this code to an MCP server. Oh, sorry, I'm not sure what's going on with my clicker. Okay. All right. Yeah. So in this case, this code is for executing bash commands, right? But again, you can essentially convert any code accessing any system into MCP with just, for example, in this case, 3 lines. And let's see how this actually works in action. So I have a few examples. First one is just a code over here. So essentially, I'm here implementing the MCP client. So I won't go over the code itself. I will share the link to the code if you would be interested in trying it out. But basically, over here, I will be using 3 MCP servers. And as you can see, first one is given access to file system. So it allows LLM to read files. Let me zoom in a bit. It allows LLM to read files, to write files, read directories, and so on. the second one for fetching, let me, sorry, for some reason there we go. For the second one, fetch allows LLM to fetch any URL, any web page, and we will actually see not so good examples of using fetch in a second. And the last one is bash, which you just actually seen on the screenshot. So it will allow LLM to run any bash commands. So what these tools allow LLM to do is, let's skip these not so interesting examples. Let's try this one, right? So in this repository over here, I have the Docker file, which contains a few errors. So what we can do is we can ask LLM to, let me execute this. We can ask LLM to try to run the Docker file. Hopefully the internet connection is working. Yeah, it works. And fix the issues if it doesn't work, right? So you can see the LLM first decided to list the files. It notices the Docker file over here. Let me switch to my clicker to a proper thing. And allow terminal, right? And OK, so it found the Docker file, it found the Python file, which is named file.py, which obviously is not a proper file. So it decided to check the content. So it was able to essentially access my local file system and local files. It then tried to build the Docker file, and it stumbled upon the first error, right? So in this case, the base Docker image doesn't exist, which it recognized. And, well, it started fixing it, right? So it updated the Docker file itself, switched to 3.12.6 Slim. It then tried to build again. Let's see. Yeah, and in the meantime, it also, I think it did this as well while fixing the image, but it also noticed that there is some missing library over here. So the script requires pandas, but only NumPy is installed. So it also, while updating the Docker image, it also updated the pip install command as well. So in the end, it was able to essentially run the Docker build. It was able to run the container and got the actual got the actual result over here, which is correct one, 4.4. So essentially, again, it was able to fix all the issues, all the errors on its own without us intervening. We just gave it the command, or the query, and it was able to access our local file system. It was able to find proper Docker image and fix any issues which might arise. But of course, this is a sort of toy example. Let me show a few examples of which are more closer, I guess, to our real work, right? So through MCP, and by the way, here's the QR code for the repository if you want to play around with the code. We will get back to this notebook in a second for the security part. But yeah, if you want to play around, feel free to scan it. All right. So a few more real-life examples, right? So what you can achieve through MCP. So one combination is, for example, Jira, or if you use something else, it can be also linear MCP or whatever. Then GitHub and Git. So those three tools allows LLM to interact with these systems. And for example, pull a ticket, solve it, and then make a pull request. And let me do this. Let me actually show this in action. So I will tag the Jira ticket here. Let's choose this one, for example. Ask it to solve it. Create branch DevOps, and create pull request. So in this case, I'm using our sort of native integration with Jira, but basically you can achieve the same through Jira MCP. So it did pull the ticket from Jira. It started going through the repository and started solving it for us. Now, while it's doing its thing, we will let it sort of work on its own in the background. In the meantime, I will show another use case which might be useful for you, which is Kubernetes. Right? So I'm assuming a lot of you use Kubernetes in your everyday life, and you can give LLM access to your cluster through another MCP, Kubernetes MCP. And you can do things, well, first of all, something simple, right? So let's see, are there any pods in state other than running in backend namespace? And hopefully I don't have any crash loop pods in the namespace, but basically, as you can see, it is using the tool for listing namespace pods, and it got the results. So in my case, all the pods are running, and I have 30 pods. But then, of course, you can also ask it, for example, to pull some logs if there are any pods in crash loop state or whatever, and then help you fix them. Then, of course, again, create a commit or pull request and so on. Now, let me go back to our other agent, which was doing something else here. So it will take some time to do all the pull requests and whatnot. Of course, as you can see it now, checking out a branch, and it will run for a while. So I can show an example of what it would look like in the end. So let's see this one, for example. So it would create quite a nicely documented pull request. It's probably whenever nowadays you see a nice pull request, it is most likely coming from AI, not from the people. But yeah, as you can see, it contains all the changes, right? Describes all the changes in different languages, in different SDKs, some benefits, some testing, mentioned a related issue. So essentially, it produced all the work for you, changed a lot of files in this one. So yeah, basically, all you had to do, all you had to ask, is go to the Jira, pull the ticket, and solve it for you, right? So and then it would create all the things for you automatically without you even needing to do anything. You might then review it, of course, but you might also ask AI to do this, or just if you're feeling lucky, just merge it, and that's it. All right. Let's go back to my slides. Let me put this thing back to the other screen. All right. Right. So here, that was like a few examples of what you can do through MCP. But of course, MCP, while it is a powerful tool, it gives you a lot of capabilities, or extends LLM capabilities to a lot of different features, a lot of different systems. It also comes with a lot of issues, so to speak. So again, you've probably seen a lot of news, a lot of articles about MCP servers being hacked because they are actually coming with a lot of vulnerabilities in reality. And some of those are, first of all, the usual suspects are MCP servers are essentially a third-party code which you run on your local system or maybe on your server, which means that all the usual issues which might arise from running third-party code on your system are there, right? So there could be package name hijacking, there could be malicious code inside the actual MCP server, some dependencies are vulnerable, and so on. So all the typical stuff you might find from running any non-AI related tools are found, of course, in MCP. And that's a bit worse there because all of MCP servers are also wipe-coded. So it brings a lot of vulnerabilities coming from that also to MCP. But at least from this, you can protect to some extent using already known tools, right? So you can use Sneak or whatever you use for static code analysis. So essentially, those attack surfaces are at least sort of known, and you have ways to protect from them. However, the problem is with AI being part of the whole system here, there are new ways to sort of attack or hijack your system through what I call social engineering for AI. And all of those issues, all of those attacks, they are essentially coming from, to some extent, prompt injection. And prompt injection on its own is a special, prompt injection, right? Injected string of text into the prompt, which makes LLM do something else, not what it was intended to do on its own. So let's say you as a user ask what's the weather like in Riga, and then attacker injects a special piece of text into this prompt, asking LLM to do instead something else. And then if it's successful, if this attack is successful, the LLM will do something else. And we will actually see an example in practice in a second. And all of the rest of attacks, they are kind of, to some extent, can be called prompt injection. So first of all, when it comes to MCP, you have tool poisoning. So as I mentioned, there are a lot of different tools which come from the servers. So you might have one of those tools essentially poisoned, right? So the tool itself might contain some illegal instructions. It might execute some malicious code and so on. So essentially, even though the whole server might be fine, there could be one tool which might be malicious. There is also tool shadowing. So as I've shown a couple slides ago, each tool contains name, description, and so on. So you can imagine some malicious server naming the tools the same way, and then AI can decide to choose the malicious tool and use it for, well, malicious things. And then, of course, again, any MCP server is essentially executed code. And you can also ask AI to execute code through MCP. So, for example, you've seen the example through bash, right? So any bash command would be executed by AI. And of course, it can also lead to some unexpected consequences. But let me show a few examples of how it would look like in practice. Again, let me go back to my notebook over here. And I have 3 pages. So let me open them. See, localhost. It is 1, 2, 3, 5. Right. So here's our first page. Nothing fancy, right? So just a hello world. Nothing too suspicious. I also have another page which looks the same. So it did load just in case. Let me reload. So you can see it is the same page. And there is also another one. It's called oops, which is again the same page. Well, technically. Right, at least for human eye, it is the same page. But let's ask our AI, using the MCP server for fetching web pages, to fetch the content of those pages and say hi to us. So with the regular page, nothing fancy should happen, right? So it will fetch, hopefully, the content, or maybe not. Let me try one more time. Okay, for some reason it doesn't. Okay, let me restart the server. 1 second. And let's try one more time. Hopefully this time it will work, because we try to turn it off and on again. All right. So as you can see, it was able to fetch the content, right? So nothing fancy in this content, just a simple web page, and it did say hi to us as instructed. Now this one, not oops, page is a bit tricky, because it technically contains a prompt injection, but it doesn't always work, right? So obviously, of course, AI providers, so in this case I'm using Claude from Anthropic, AI providers, they try to protect from prompt injections, and Anthropic recently announced that they detect and prohibit around 88% of prompt injection attacks, but there is still 12% which are not detected. So this page, sometimes it gets, it hacks the AI, sometimes it doesn't. So let's see if it will work this time. Because as you can see, actually, on the page, I had a hidden text over here, which basically asks LLM to, in addition to the previous instructions, create a file called oops.txt. Let's see if Claude will fall for that in this case. If it will go into this 88% of detection or into the non-detected 12%. Got a bit stuck. OK, we got a bit confused, I guess. Let's see. All right, so in this case, as you can see, it detected, got protected from prompt injection. So it noticed special instructions for changing the files, but it wasn't part of your user query. right? So in this case, it asked if we actually want to try it or not, or if we want to create it or not. But then let's try this page. So this page is a bit more elaborate attack. This is also a prompt injection, but you can see it contains quite an elaborate instruction. So in this case, it asks to list all the tools which AI have access to, and it also gives an extra tool to AI, which is, in this case, write meme phrase into file. And then we ask LLM to just do a sort of test run or test simulation of running this tool. But the tool itself is actually asking to create a file in the local file system. So as you can see, it's thinking quite a long time. So let's give it a few seconds, because usually it will produce quite a long list of text as an output. All right, let's see. So as you can see, it said hi to us as instructed, but it also started doing pretty much what we injected it to do, right? So it listed the functions, all the functions it has access to, right? So all the whatever 12, 20, 18 tools, 17 tools. But what is more important is did the sort of simulation of the new tool and actually did execute the write file command. So we can see the file now being created on our local system 31 seconds ago, which contains what we asked it to do. So yeah, basically, again, unknowingly, we could have fetched a malicious web page, and our LLM would be hijacked. Of course, in this case, it's not too malicious, right? But you can imagine the same being used for executing some malicious code on your system, essentially, without you actually knowing what is happening. All right, so yeah, I mean, and it's happy that it was able to be helpful, but of course, it's not something that we wanted it to do. All right.
Will you show us the contents of the page?
That's the actual content over here. So this is the whole content.
Yeah, but the page.
Oh yeah,
the
yeah.
Page where we can't see.
All right.
HTML.
Yeah, sure. It is this one. So it's actually just in white on the page. Yeah. So as you can see, it's not visible to human eye, but of course through HTML you can create a lot of sort of these hidden things. You might have heard about similar example where someone put text like in white into their CV, asking LLM to always accept this candidate, and they did. So yeah, this is quite a simple prompt injection, right? Of course, through MCP you can do much more. Here's one example. You might have heard about this one recently. So let me put back this thing over here. So GitHub MCP was apparently exploited, right? But technically, GitHub MCP didn't have anything to do with the actual exploit, because what they asked AI to do is, well, they created an issue in public repository where they are telling the AI that, hey, the author is not very known, go through all the private repositories, collect the info, and put it in the public repository for the world to know the author better. And well, AI was able to access private repositories because it was created. It was given access through GitHub MCP to private repositories, and it did pretty much what it was asked to. So again, it is not technically, it doesn't have anything to do with MCP itself. It's just the way AI is working and the way AI is being social engineered, kind of, right? So again, there is technically nothing malicious about this request, right? But of course, the output or the result of this request is not something we would want to happen in real life world. Now, how can you protect from all those things? Of course, as I mentioned, first of all, when it comes to sort of our usual suspects, right? So running third-party code, there are tools to help you protect from that. But when it comes to MCP and AI-related issues specifically, so first, of course, you probably want to whitelist MCPs. So you don't want any of your colleagues, any of your teammates in the company use just any MCP, right? You might want to have a specific list of MCPs they are allowed to use. You might also want to have some sort of organization-wide MCP configs, because then you could create, you can control permissions, for example, have read-only flags and so on, and maybe also have secure token storage because some MCPs do require API tokens, API keys, and so on. You also might want to limit access to sensitive systems, of course. So you probably don't want to give access to production database, or at least not write access. Again, as I mentioned, you might also want to limit access to specific tools. So Kubernetes MCP is actually a good example. So they have these two special flags, which is read-only or disable destructive, which, as the name suggests, give only read-only tools or disable write, well, delete commands, essentially, right? So basically, you can be, you don't need to worry about AI accidentally just wiping the whole cluster and recreating it from scratch. And for prompt injection, it is a bit trickier because, as I've shown, any web page can technically contain prompt injection. So what you want to do here, might want to do there, is first of all to use some intermediate or proxy tools. So for example, when you are fetching web pages, when you're doing or when your AI is doing web search, you might want to use special services which do essentially AI web search. So I actually mentioned Exa when I showed the list of MCP tools, MCP servers. Exa is one example. There is also Perplexity. So you probably heard about Perplexity. It's more known. And they allow, through API, they basically allow LLM to do the web search through API. But then they also summarize the results. They also do some protection from prompt injection. So essentially, they might remove the malicious piece of text from the web pages and give you LLM only the sort of safe content. Or if you are using some other indirect way to get data, you might want to use some sort of proxy, again, similar to what I mentioned for web search. And that's, I think we are about time. So that's a few QR codes for you. So on the connect one is, of course, for my socials if you want to connect. This one, I didn't talk about Zencoder a lot, but yeah, if you want to try Zencoder, which is an AI coding assistant, feel free to scan this QR code over here. Now, do we have a time for questions?
Yeah, we have 5-10 minutes for questions, so feel free to ask.
Great. Right. I guess no questions. All right. Well, feel free to scan QR codes and all right. Okay.
About the protection from this malicious queries like you showed,
Yeah.
text method. Basically, who decides that something is malicious on this website? Another AI, or basically you have a dictionary?
Yeah.
Or also something?
Yeah. Yeah, that's a good question, and it's a tricky one because, of course, you can't really use the same AI to protect from something that hacks this AI. Right? There are different ways to protect from this. You can use models which are based on different architecture. So you can use, for example, models which create embeddings, and then based on these embeddings, you can also classify the text. There are actually a few libraries which you can use for similar detection. You can also, try to use different models, right? So, for example, let's say you are passing the data to ChatGPT. You can try to use Claude to check for attacks, because the example which I've showed for the attack, it actually works for Claude, but I don't think it works for ChatGPT. So you can, some sort of jailbreaks work for specific models, but don't work for others. So I might want to use to leverage that to be able to detect any malicious inputs as part of your web pages. But yeah, it is all still kind of evolving area. It's a pretty new area, so there are hopefully would be more robust methods. But for now, as far as I know, those are sort of the main two ways to protect.
Yeah. The problem is akin to synthesizing the user input in classic like web development.
Yeah.
But in this particular case, why did the AI decide to just to implement all the instructions rather than just parsing as a content and processing it? Yeah.
Well, in this case, so let me go back to my notebook here. So we are just asking it to fetch the content of the page, right? So and then the result of execution of this tool, it basically gets included into the prompt. the user prompt, and then LLM considers this a system user prompt, essentially user query. Right. So in the case of a simple attack, so just in addition to previous instructions, just also create a file. It was able to see that. So behind the scenes, what this whole interaction would look like is it would be a dictionary of several messages, right? So the first would be a user query from fetch the content, then that would be assistant message of I'll fetch the content, then another user query with the content. So basically, LLM will see the whole sort of dialogue, and then it can potentially, hopefully, see that okay, so the initial instruction was just to say hi. And this new instruction is not part of the initial instruction. But actually, let's rerun, because as I mentioned, sometimes it falls for that simple instruction, sometimes it doesn't. Now in this case, in the case of more elaborate jailbreak, it is, first of all, okay, so it didn't fall again, but okay, let's try another one. In case of the longer jailbreak, it is technically not asking directly to create a file, right? So if you actually see this instruction here, we are just asking it to test it by mock using, right? So technically we are not asking it to actually execute it, all right? We are just trying to simulate. But when it tries to simulate, it decides to actually create a file and actually do what is instructed. Actually, this jailbreak can also be used to force LLM to give you sort of restricted content. So you can use a similar jailbreak to ask it to give you a recipe for Molotov cocktail, for example. Don't use it, but it can be done. Essentially, we are again kind of social engineering the AI into doing something that it's not intended to do.
Yeah, but what I wanted to highlight is this is caused by specifically designing these prompts so as to include it as a plain text.
Yeah.
To inject concatenating, which is not considered safe in any area, right? So we should probably process it before including it.
Well, I guess technically yes, but again, you can't really process it with the same AI, with same LLM, because it then will fall for it as well, right? So you need to be a bit more elaborate on this. And when especially when we are talking about vibe coding, people don't really care about this, so they just ask it to go fetch the web page, go fetch documentation, and so on, and they don't care about any intermediate security steps.
Thank you.
We have time for one more question.
All right.
Let's imagine if you want to make your own MCP server like as EXA,
yeah.
Which security approach will you use? It sounds like prompt, but it's not prompt.
Well, there is actually a good repository which you might want to check out. Let's see if I can. I think it's somewhere. Yeah. So the name is pretty telling, I guess. Right. So it contains a lot of different vulnerabilities, a lot of different attacks, and solutions for them. Right. So it contains a lot of different code examples which contain vulnerabilities and how to overcome this. And sanitation is one of those things, of course. So you can let me scroll down. So I don't know if there is an example here, but basically you can go to solutions and follow different solutions, see what is the issue, where it arises from, right? So like in this case, I believe the code just injects the user ID directly into the string, which leads to potentially code execution. So you can check it out. There are a lot of most common issues when creating your own MCP server and how to overcome them.
Thank you very much, Alex. Before you go, there's two more things. First of all, can you please, out of the 3 people who asked you a question, tell us what was the most interesting one to you personally?
Okay. Well, I guess the one about protecting it from person in the back, right?
You, my friend, just got a softball. Congratulations.
Thank you.
You're welcome. And for you, we also, Alex, have a little present.
Oh, wow.
Thank you very much.
Thank you. Let me move all my toys from here.
Okay, I'm gonna do my part of the deal then. So, okay. Up next, we are gonna have our lightning talk speaker. Just a second. Technical difficulties, you know how it goes. So yeah, for our lightning talk, I would like to invite on the stage Ivan Weinberg. So Ivan, where are you at? Hello. Welcome, please welcome our speaker. Here you go.
Clicker?
Yes. It's this button. Of course.
It doesn't work.
You should press here, the lower button.
Nope. I don't know, but how do I switch the slides?
Is the clicker connected?
I'm not sure.
Is the clicker connected? Show me.
Mhm.
The clicker is not connected.
Ah, there we go.
Okay.
See,
Then okay. I was just using.
I'm an engineer.
Shift happens. All fine.
Probably will need to restart the sliders.
Do we have a batteries or we need MCP server?
It
Should
works.
be,
Oh,
should be
thank you.
set, yeah.
Down, push down.
Hello, everyone. Okay, so today for a lightning speech, and thank you very much, Alex, for inspiring presentation. Definitely will check that out. And most likely I will partially answer the question how to protect organizations from security perspective, because simply that code wouldn't go to production during the code review. And you've mentioned about Sneak. Definitely it's not a promo session and I won't sell or promote anything. Just briefly touch some of the topics because I have another release to make in 1 hour, so we're gonna keep this fast. There we go. Okay, briefly about me and our company, what we do. 28 years in IT and 19 in management. There were some maybe known and heard projects, and maybe you've been using these on your daily basis, such as code calculators within the mobile banks. We were the first in Europe who invented it by passing all code reviews and embedding it into mobile clients, primarily in Latvia and later on all around the Europe. And recently, the case which I'm about to demo would be integrating a payment gateway and specifically would cover SAST. Some of the certification which we have. Yeah, and basically the problem, definitely problem, is that we fix something, then someone is doing redef and refixing the problem, and then we sometimes need someone to maintain it and refix it. Been there, done that. Who did it? Raise your hands. Yes, there are some. Yeah, so you with me. Okay, and nothing new there. Since actually before I was born, people came up with, in university, IEEE, university came up with a standard and structured all different kinds of errors. And I've highlighted some of the errors starting from syntax errors, basically logic errors, functional errors, security, and of course testing. And you've heard this many times. If there are any people doing both management and development routines, there is a saying, say, oh, well, it worked on my machine. Then we probably should wrap your machine and send it to the client. So this is how, by the way, Docker was born. Okay, and to highlight the standards, as mentioned, it started in '84. and evolved basically down to year 23 with a model called standard called Kokomo version 3, and adjusted with AI and also remote work. And you know how working from home feels like, right? Right, so the goal that I would like to point out wouldn't be resolve the errors, because every single system would contain the errors still. So the goal would be to minimize the errors, covering the following criteria, like stability, availability, regression scope within the QA, if you have a QA in your team, security, obviously, and of course, saving the resources as much as we can, the people, time, and money. Right, so within this concrete case, I took one of the enterprise, wouldn't disclose the name, but as soon as before the update, we have measured the following metrics slash KPIs and defined some targets. And the idea of this change was to try to keep the amount of errors as minimal as possible. And who's with me here? DevOps? Anyone? Yeah, I hear the laughs. Yeah. So I've been working in United States. I had a contract, worked as an IT architect in real estate company, and that quote actually was one from one of deployment nights when we had later on. Hey, let's push it to prod. We just did a small change, and then everything crashed. And obviously, we had this famous quotes like, "It worked on my machine. Well, it somehow deployed itself." So, but and I still remember the quote from PM. It's like, "We are 80% done, but it's not that scary as the rest, next 80% of the project, you know?" All right, so as Alex mentioned previously about Sneak, right, via this Y thing, I won't promote, as mentioned, any tools. Just would like to highlight from a real production case which helped us to keep amount of security errors as low as possible, integrating some of the tools. Clicker, yeah. So yeah, basically would promote one of the tools, that would be Jenkins, DevOps. You probably heard and know this tool. But that was before, actually before it went to production, we scanned it in QA and received some of code recommendations, I would say, and marking the ones and trying to resolve in a first place high/critical ones. And since that was a legacy project written in Visual Basic, there are projects like this still. So basically, you normally don't touch legacy, right? And we somehow had to fix this. I would call it inheritance in a diplomatic way. So yeah, we resolved high vulnerability issue related to SQL injection. And later on, we received clean report without the errors. And this process can be hosted either on-prem or in cloud. Yeah, so basically right after that was done, we did manage to minimize and reach the target, resolving the amount of issues in less amount of time. And also repeated vulnerabilities were narrowed down from 22% to 4%. And you can check the rest. Right, thank you very much. And if you would like to stay connected, you can scan my QR. And I hope that we're gonna meet again. And yeah, we can cover more interesting topics in more depth. Thank you very much. Do you have any questions? If we have time, of course.
Yeah, we still have a
Yeah?
bit of time.
That's good. Yeah, please.
It's very interesting numbers on the last slide.
Yeah.
These passages is, you know, a joke for how scientists invent a new material.
Yeah.
They invent something. After that, go to time machine and change the topic what they want to get, and after that they get it in the final. So my question is, why this target very closer to the real result?
Which slide was it?
Last slide with the numbers of personages and how we get so close result to your target.
I should probably follow up with my team on that, but this is the
very close to.
You mean this and that?
Yeah. It's very strange because how do you know what's target?
We can connect with you and evaluate together, but as I mentioned, these numbers are taken within real enterprise, the one that we calculated, and I'm happy to share how without disclosing the names if you're still interested. But at the moment, yeah, need to follow up with my team on that.
Okay. Just close. Very good.
Yeah, but it's a good point. It's a good point. It's a good point. Yes?
Were there any problems in selling the idea that these issues, which are basically technical,
good one.
neglect?
Good one. Yeah, because I started doing the code reviews where we sat together within the team, at least 3 people, and normally we had this comment LGTM, standing for looks good to me. Because we try to avoid subjective opinion, but rather have objective opinion on the topic and, communicate on that. So it was tough to sell it for business, but luckily I represent my business, so it was a bit easier. But we were basically comparing the outcome from what's the difference from regular lint code reviewer versus the one that is more oriented towards security. And yeah, so it wasn't a big number to pay for this solution. So we could easily give this a try, and it had its benefits.
Okay, you can always catch Evan during our break. Unfortunately, as of now, we don't have much time. But thank you very much for your lightning talk.
Thank you very much.
I also have a little bit.
Oh, thank you. Thank you. Thank you very much.
Thank you. Also, before we go on the break for 15 minutes, I would like to mention that, as you can see, we have a setup here. So if you ever would like to trace back...
Okay, thank you. Am I on? Does it work? Does it work or not? Do you know? Should I start? You're not very communicative, I see. All right, so the name of this talk could have been something like, let's make Eclipse great again. Yeah, but if that would be the name, would you be still here? Probably not. So this name is a little bit better, obviously. But then there's a lot of content. Let's just jump into it. So sciencing DevOps with model-driven and LLM code generation. Riga Technical University. So immediately an explanation, or let's see what was in the slides. I don't really recall. So that's me. Most of you know me. I believe so. The most interesting part is, here's 2018. Was it correct? It was. I got it right. But that's me. That's the professional experience. That's history. But today is more about my research experience. And then in 2010, I finished my bachelor's, and then 10 whatever years later, in 2024, I became a PhD student. Or in 2023, I don't even recall anymore, it's been wild. And last year I went to Valencia to meet this great guy. I lost the name. I'm sorry. Wait. Oh my gosh, I forgot. He was hosting me. He is super famous person in the world in a model-driven space. And then who knows what model-driven engineering means? Like, no one, but he's super famous in that. So maybe that's why. But it should be, anyhow. And then here this year in Tartu, I meet another Raimundas, Lithuanian in Estonia, who also has been working on model-driven engineering topics 10 years ago. Yeah, this guy does it. Pastor, it's coming back to me slowly. Pastor. His surname is Pastor. Still trying to remember the first name. Anyhow, so here's my publications, and it's all around DevOps and obviously and model-driven. So what I do, I research pipelines. For kind of since day one, I started my first pipeline in well, 20 years ago, roughly. So in 2005 or so, I started my first pipeline. Pipelines did not exist back in the day in 2005, but kind of continuous integration was the first thing, cruise control, .NET. If someone has heard such a name, those were my first tools. Well, today it's more, not the Jenkins really, but it's cool to talk about Jenkins. We saw everyone talking about Jenkins. We still love Jenkins, right? But today everything is around GitLab. Also, my work is mainly around GitLab. But then, so pipelines. GitLab pipeline. I hope you recognize it. You're full of DevOps folk. And then this is easy. We just make some code for it. We make it. But what if we have 100 pipelines for your microservices architecture, type of architecture? What do you do then? Smart people would say, well, you make a library for your pipelines and then you reuse it in an OOP way. How many actually do that? Typically, we copy-paste the nice pipeline code and adjust it, don't we? So is there another way? And that's what I've been working on. Is there another way? So we'll see. A little bit on manual DevOps pipelines. They don't scale. Those 100, they don't scale. And then how many DevOps engineers here today, or DevOps specialists, whatever, how you identify yourself? Could you please raise a hand? Who is DevOps tonight here? More hands. I want to see more DevOps. A half, definitely a half. And then this is how our life goes. I hope I'm not some kind of imposter right now. This is how our life goes. We get all kinds of weird requirements from everyone, and then we are supposed to make a product out of it, generally. And then what do we actually do? Develop new automation modules, then other tasks. That's cool. But then there's glue existing modules into new pipelines. This is the OOP approach. This is at least gluing something together instead of writing from scratch. And then we spend a lot of time reconfiguring existing pipelines. And that's what we do. It doesn't really matter, is it infrastructure pipelines, is it CI/CD pipelines, is it MLOps pipelines, it doesn't really matter. So I don't know, do you agree, but this number, but my experience from project to project shows that a good modern team, a good modern project or product requires about 10% of DevOps capacity. So basically for a 7-people team, you need 1 DevOps, which is a lot. It's more than 10%, actually. It's a lot. Typically on 2 teams, typically on stable projects, 1 DevOps supports 2 teams, something like that. But it's a lot. It's a lot. Do we need a full room of DevOps? Probably not. So I'll try to automate some of our work. So, and now we're getting to, let's say, science. And surprise, surprise, science is nothing more than cool ideas wrapped in nice words. That's my learning from my PhD journey so far. So could software architecture diagram be enough to make a pipeline? To make, yeah, you know how to make pipelines. If you know what's going in, let's say for this case specifically, we want to build a small Python app on Flask, which, well, you have a pipeline to put it in a container, to run some tests, to push it to registry. That's it, a very simple pipeline. If we know that this is that, do we actually need to have the pipeline knowledge? Kinda not really. So, and here's we start the metamorphosis. So here's the very simple model of that case what I just described, kinda. We say it's one component, it has unit tests, it has some linters, the type will be jar. Well, forget about the chatbot, this example is for Java specifically, doesn't really matter, and the build system will be Gradle. That's it, nothing else. The rest we can transform and generate. So we move to a more sophisticated model. This we would call PSM in this case, or PIM, doesn't really matter, I'll explain later. And then here we have generated the code, the actual GitLab pipeline, and here we have the GitLab running. Magic? How to do that? Am I out of time? I hope not. I should move faster. Yes, thank you for the reminder. So can we abstract ourselves from that? Can we create an engine which makes pipelines for us? And someone probably says, hey, but there's auto DevOps in GitLab. It's not the same, a completely different thing. So, but we could have an engine which takes care of all the routine DevOps tasks, and then the cool parts, the fun parts of the job, like developing new transformation rules, or other DevOps tasks, some new refreshing, innovative tasks, that's what we should be spending our time on. What does this mean? So instead of developing pipelines, we should be moving up and kind of abstract from the issue and work on transformation rules instead of low coding of the pipelines. If we could do that, that would be amazing. Let's put it this way. My imaginary estimation is that this way we could pretty much kind of double down, split, I can't find the words in English, 2 times less DevOps would be required on the team is my kind of rough assessment. So what I'm talking about some kind of fantasy, right? A little bit of fantasy, kind of. So has this been done before? And this is kind of how the science is done. We start with the research. Has something like that been done before? As engineers, we would start with, let's code it. No, that's not how we do in science. So that's the key difference, really. So a research has been done. Some 13 or so different cases, similar cases have been found. I personally went through lots of things. I was super happy to see in Alex's presentation an activity diagram, a UML activity diagram. There was one. Some people call it sequence diagram. People still kind of argue which is what. I get confused, but a lot of engineers do not know what is activity diagram. Thank you, Alex, for having that. So here we have the UML class diagram, UML deployment diagram. Spam is from a different notation, orientation models, some kind of, no one uses that. UML activity diagram here. So through diagrams, can we design a pipeline so that we can generate it? So this is a, I think, publicly available publication. You can find it. You can ask me if you want to read it. Yeah, and 6 of those results generate pipelines for Jenkins specifically. GitLab, not that much. The coolest thing, what I found, kind of what people have created, there are some 3 cases or so which are cool. This one, it's called StockCD. You will not find much information on the internet about it. It's commercially locked down. Someone is trying to make some business out of it. It's not clear, but it started in some university where they managed to use code to put diagrams into the tool and take diagrams out of the tool. So they're kind of moving to this diagramming approach. It's a little bit more kind of, it's on a higher abstraction level than some kind of low-code approach where you put boxes like build, test, this, that, deploy. This is a little bit more kind of on a higher abstraction level. This talks about business processes. So that's cool, but it's still, it's not what I'm looking for. This one still, it requires more or less to write down specific steps and whatnot. I'm saying we don't need that. If we know how to do pipelines, if all the pipelines are kind of the same, then let's automate that, because all the pipelines are kind of the same. The engineering process as such is for each project kind of the same. So let's try that. So we move to model-driven engineering, which is more, a lot of companies have tried to make business out of it. Some are a little bit successful, but the engineers often haven't even heard the name. But it starts years ago. This is case tools. Who knows what are case tools? Who has been to Riga Technical University to some courses? There someone mentions case tools. Then around these case tools, around 80s and 90s, and later on, someone tries to create a methodology which basically says you should have two streams for product development. Basically, a few engineers work on models, a few engineers work on UIs, and that's it. No coding. In reality, it didn't really work out. In reality, there's so many challenges. The whole MDE approach, you don't know about it. There's a reason why you don't know about it. There are issues with the whole kind of philosophy. But anyhow, we have UML, which is kind of related to the whole thing. First time published in '97, got updated for many years, but kind of rather stable for 20 years as notation, as a diagramming approach. Then the Eclipse in 2000s. And then after 2000s, there's Meta, Edit Plus, and whatnot. But kind of after year 2000, not much is happening in MD space. And well, there must be a reason for that. It kind of doesn't work. Of course, the Professor Pastor would say that he has created a magic tool, and there is a company in Portugal. No, I wasn't in Portugal. I was in Valencia. That's how well I remember my time in Spain. Obviously, but yeah, and there is Intel something who are trying to build business out of it, and they're successful in their local place, but it's not globally popular. So yeah, that's the reality, and still kind of I believe that I can use that. So this is the 30 seconds of model-driven engineering. So the whole point is, you have an input model, so a model, some boxes, a picture, yeah, a picture. Then there are rules how you can take that model, the picture, and transform it to another model. A picture, also maybe a code. That's it. Every model must have a meta model. A model which describes model. This is where things get a little bit confusing. I will not go deeper than that. There's specific notation, specific acronyms and rules and whatnot. I have a book at home written by Professor Pastor, where at the middle of the book I was like, okay, this is too much for me. I don't understand a word anymore. So it's a complex topic. But then, this is what I want to achieve, okay? No, this is not what I want to achieve. This is MDE. Okay, this is MDE. And imagine if you could have an input model, a code of GitHub Actions, yeah, a pipeline for GitHub Actions, and you run it through an engine, and it gives you a pipeline for Circle CI. And this project, this is the second cool project. I don't remember the name exactly. Actually, last year, a few people in Portugal, that's why I mentioned Portugal, a few people in Portugal created a tool like that in university. It's master's thesis for one student, and there's a couple of people. They created this using this approach. That's cool, but still, this is useful only for cases when I have a pipeline. That's not my case. But it's cool. It actually works. It's doable. It proves that it's doable. So what's happening in the middle, just to explain, this gets turned into a model. A picture, basically a picture. Then the picture gets transformed to another picture, and that other picture gets transformed to this code. Yeah, code to model to code. This is my concept. Finally, we're moving to kind of my solution, what I'm talking about. Why it says MDDO2 dots? Because I invented this name 2 days ago. The original name is the other name. But if we look at this diagram specifically, it does model-driven DevOps. Quickly, what do we see here? Here's remember I talked about software architecture or system architecture, the one component, and that gets transformed to a DevOps pipeline, an abstract DevOps pipeline model, which gets transformed to platform specific, so either GitLab, Jenkins, Azure DevOps, you name it, to that specific model, which then gets generated to actual code. Here's LLM. Oh, sorry, then it should have 2 more letters there. So with using the power of LLM, we can improve the code even further. Catch the drift, or what is the naming? If you see here, this is Eclipse, this is Eclipse, this is Eclipse. Eclipse actually back in the day was something amazing. These tools still work, they get updates, it's just no normal human being uses Eclipse anymore, but you can't find these tools in visual code. There's no such functionality. Then I would need to code it from, if not 0, then from a low level. So I will not show you a cool demo like Alex showed. I will show you fake slides, yeah, you know, but it's actually a real thing, a real solution. But I'll tell you about it backwards. Because it takes an effort to kind of go through this model to model to model to model to code. Yeah, we'll go backwards. So we start with the software architecture to going backwards. So we start with the end state. We want a pipeline. So this pipeline does a very simple things. It's a GitLab pipeline. It does a build. It does a test. It builds. This is still the Java example. It's not the chatbot example. Okay, forget the word chatbot. Java. And then it does some unit tests, and here's the PMD for well, SAST. Well, not SAST. SAST is for security. So this is it is a SAST. Whatever. Static code analysis. That's it. Yeah. So this gets not transformed. We get to this from a model. And model looks like this. And this is Eclipse. Yeah, this is how Eclipse looks like. So see, a little bit complex, yeah, but if we would start reading it, we DevOps people would start recognizing a few familiar words. Like here's reports for JUnit, path, where to put reports. Randomly, here's a job. We know what a job is. Here's the actual pipeline. Here's some variables. Here's some artifacts in the output. And actually, this could be restructured in a little bit more readable way, but this is generated. This is generated from. So that GitLab model from previous slide is transformed from platform independent model. Independent, which means, can there be a master pipeline? Yeah, this is a master pipeline. It's not about Jenkins or GitLab. It's a one pipeline, abstracted one pipeline for anything. And that one looks like this. This is the master pipeline. It has always a stage build, always a stage test, and some linters. In this case, we give a parameter that it's gonna run with the Gradle. That's it. This is very abstract. It doesn't say Jenkins or GitLab. It doesn't have to, because all those pipelines are similar. So how do we move to that, or more of each element of this must be described in a meta model. So that's a meta model. I will not try to hurt your brain even more with that. If you want to, I can give you a book by Oscar Pastor. Honestly, I'm not joking. It just came to me. Yeah, sorry, Oscar. I'm Professor Pastor. I'm very sorry, honestly. Yeah, and then this is the input model. Creating this with the UI should take for the person, what, a minute? If the person knows what needs to be done, how the ecosystem works, how the IDE works, how to make it, then this, with a few clicks of the button, typing in some text, this says one component with the name Hello World CI, language Java, build system Gradle, the output is jar file. Maybe, well, if we would go further, we at some point would say, well, this says Java, so it's clear, Java, and here it is. And the rest, where we put files, where we put directories, everything, it's standardized. If you think that you can put directories wherever you want and put those Java files wherever you want, no. It's standardized where you put your Java files and test files and source files. There is a standard structure. Use it, and then this is going to work as well. The same for pretty much any programming language. So this is not for Java only. It already is working for Python. That's why I said chatbots. It is in my company working for our chatbots. Yeah. And then this is a meta model for software architecture model. Don't hurt your brains. We move on. Then this is the summary of what I just showed you, but from the beginning of it. Yeah, here's the software architecture model. We use ATL. It's a specific coding transformation rules coding language. Then here are the meta model. Here's the platform independent model, which then, thanks to Axelio, which is another Eclipse extension, from this model we generate the code. So this has rules how to take these elements and turn them into specific lines. Yeah? Cool. Now, so that was the demo one. I promise you it works. I've seen it by myself. So the demo two, from manual fix to a new rule. So how do we add, the next slide explains it. How do we add, so this is a simple pipeline, and let's say we want to add a tag to that tool, to what the tool outputs. We want to add a tag, and in this case, it's in brackets MDDOAI. How do we do that? And this is how do we do that. What we have to do with a tool to add more stuff to generated output. And this is where things get truly kind of, this is where you need an engineer, this is where you need a developer. So an explanation, create only branch, you need to create a lazy rule. It is ACL terminology, create a lazy rule, create only branch, from branch name, and here we give an input the string, what's going to be the branch name, to, and it's going to be branch, specific to GitLab, we make branch, and then the branch name goes into the branch. Yeah, if you don't know ACL, then this you need to learn a completely new programming language, well, transformation language. But once we kind of commit it, then the GitLab pipeline of the MDDO AI, MDDO, right now MDDO runs, it builds kind of itself, it builds a package in the output, and that package, a small, what's in the package? It's a Java package because Eclipse is on Java. That package we push to our repository, to our product, to let's say my chatbot product. I push it there. This part I can automate all this part. This pipeline is written manually. MDDO doesn't build MDDO, so that's done manually. But then the output, the new version of this package, I push it in my product, and then automatically, at least in GitLab, it works nicely that you can generate a pipeline which is a master pipeline, and you can configure it in a way that it now has that, I don't know what's the name, subset pipeline, sub pipeline, whatever. Downstream is more in a GitLab language. And now by just pushing this tool, I pushed it, the trigger runs, it executes the pipeline generator, I get the new pipeline, I get that tag in the pipeline, and it works. So, yay! Yeah, super cool, super, I'm so excited, so cool. So how many now know how to do ACL? Are you ready to learn ACL? There's another acronym, OCL, ATL and OCL, which is another language for putting constraints on those models and transformations. It's another world of lots of things to learn. So anyone here? I'm still a junior on this topic. For sure, people have been mastering that 20 years ago, and now we have Professor Pastor, who is still an expert of this. So why it's not enough? So it's a cool thing, but for some reason, you don't use MDE approach. There is a reason for that. Also for pipelines. Cool, but kind of not enough. So creating those rules, it's slow. Now for every small thing, you need to code a new rule. Every new pipeline requires an update to this platform-independent model, platform-specific model, and transformations. So basically, for every new thing, you need to go through 3 or 4 levels and add it there and there and there and there. For example, for those tags. Yeah, and then rules must be hard-coded. You need to engineer it. You need to develop it. Of course, it works, but then every small kind of new thing requires, again, an engineer. If we would spend 5 mil on it, I just read that, off topic, I just read that Commander, the desktop Commander, got funding of 1.1 million. The Edgar Rusga was here 2 times this summer. Cool, Edgar. Amazing, amazing. Off topic. Yeah. But then, why I mentioned it? I forgot. A random thoughts. Then, so what if we could make AI to write those rules? Because it's hard, and it's boring. Making those new rules, it's boring. It doesn't require lots of creativity. It's rather straightforward. So what if we could make LLM to code it for us? I'll be honest with you, we haven't created an MCP yet. We haven't really attached the LLM generator to the MDDO solution yet. For now, we're just running experiments with what LLM could do. But the big difference is that now, instead of a prompt, and Alex showed perfectly how if you at the bottom of a prompt put some important information, it becomes the most important information of the whole prompt. That is a problem with prompting. Then instead, we talk about context engineering, where we start giving structured content, specifically structured to the model. The results. So is it doable? Does it work? Does it work? The answer is yes and no. And like LLM, it is yes and no. So back to kind of the demo or more of a trial or experiment. So again, we have the initial code. We want put LLM up to the job. Please add these tags, and it's for all these stages, no, jobs, for all these jobs. Here the tag, here the tag, here the tag. We want to add that. We want to ask LLM, please do this. It's a simple task, right? Maybe not a 5-year-old could do that, but it's a simple task. Give it to a junior engineer. Should be fine. But then what does it mean in the rules in ATL language? It means that basically for the lazy rule, we need to add this only, this module, create only stage. And this will pretty much add this will come out in the result. Yeah? To generate this, we need to change the transformation rule here. Yeah? And this will add it to the pipeline. Yeah? So it's model to model to model. Finally, we tried GPT 4.0. Should be enough to do a simple task. As I said, does it work? Yes or no? 30% of the time it worked, 70% of the time it did not work. And it messes up typically this from part, but very often it loses this comment on top, the header. It's not good enough, it's a big guessing game, and at most of the cases it created a wrong result. So how do we fix that? The problem is the LLM doesn't know what an ATL is. The same as you don't know what ATL is, LLM is no smarter than you. So that's a problem. LLM or GPT specifically doesn't really know what ATL is. Yes, we should try some more coding specific models, probably. I still don't believe that we would get a 100% correct result. So it gives out all kind of crappy results: incorrect indentation, wrong naming, insufficient rule headers, missing from mapping, typical mistakes in this particular case. So how can we fix that? And when we started to give in this case, in the context, of course, when we started to add in the context patterns like other examples of this is how it's done in another scenario, then it gets better. Of course, if we will make the context, I will not use a number, but very, very, very big, then we will start getting other issues and it's not going to work again. But for simple cases, this works. It gives basically 100% correct results. We added quite a few patterns, so other examples, what is expected here. So of course the next step would be, well, you can tell me, what do we need to do? Yep, we need to fine-tune an LLM, which is not an easy task to do it. That's not playing in a sandbox anymore. That requires an effort. If you fine-tune it in a wrong way, then you basically need to throw out everything, because fine-tuning on top of fine-tuning is gonna get you only in a trouble. But that's the next step for us. And then this is an invite to join this super cool, exciting project. So it has been open sourced. The whole code is available. The name is MDDOAI. You can find it online. The next steps, the next goals are to add the LLM as such, to add fine-tuning, to kind of make it in to add MLOps to the whole thing. A lot of other things, a lot of rules to develop. There's a big idea to turn it from Eclipse to Eclipse Web, so you can run it online, all that modeling if you want. So feel free to join in, or at least explore. And then, all right. Since I have an opportunity to talk, then this is a thing. It's not for the previous project. This is, I'm from Zenith, and we're looking for one person. If someone is good on Kubernetes specifically and thinking, hey, what should I do next, then feel free to join. It's going to be lots of fun. Yeah, that's it. How long did it take? I'm sorry.
You finished.
Okay, cool. I know, I finished, yes. Okay, thank you. That's it. Yeah.
I'm actually wondering how long the whole process took for you, the researching and creating some kind of a demo version with all these concepts together with the ATL.
Well, of course, it's not a full-time work like 9 to 5 or in Latvia 9 to 6, but I'd say, yeah, it's weird, right? But I'd say 2 years. Yeah, I'm a third grade student right now. Yeah. So about 2 years, the research, the development, and I haven't been the only developer. You can, yeah, I haven't been, we are 2 developers, let's put it this way. Yeah.
So I guess you started this project 2 years ago, but now LLMs have all these specification language like constitutions, which you kind of write diagrams in text, natural language, where you can describe whatever you want, and it just translates it directly to YAML, right? Which will work on your GitHub or whatever pipelines. So would you still proceed with ATL? What was the specific language to type the diagrams in? Or would you just rather start using LLMs directly?
The whole difference from what's available right now is that if you will give to any, the coolest, the best LLM a task, make a pipeline, a GitLab pipeline for me for one Java, for building one jar file. You will get a result, but the thing is that more or less every time you will get a different result, more or less. And that's not good enough. When we talk about pipelines, we need something consistent. So how do we merge the consistency with enrich it with LLMs? And another big important step is, so we want a hybrid approach. First of all, we want a hybrid approach, and then the approach is going to be that we have this modeling approach so that I can model it, but then the generation part I give to the LLM, and I run LLM as a judge to make sure we have nailed it down. And once the LLM creates those rules, we save those rules in the tool forever. That's going to be the approach. But it will take a lot of cycles to get it right. So it's a hybrid approach.
The AI, I think, has developed quite drastically in 2 years, and the constitutions and the spec kits and all that specification part of the context building for the LLMs are now quite advanced, and you can build your model, then tell it to document it, so it always regenerates it in the exact same way. And if you want to add a new feature, you just update the documentation, and then LLM will again update the end result.
That is a different angle how to approach this, yeah. But right now, this is the journey. That's, I guess, the answer. Right now, this is my journey. Yeah.
Yes, I have quite a stupid question. Sorry for that.
All questions are stupid.
If I understand correctly, you want, with this whole approach, transform from one deployment script to another.
Not really, no.
Okay.
I want to transform from a very simple description of my product to a final state as a running pipeline. So I'll give a very concrete example. What I'm using now, one of my commercial projects is, it's a rather simple pipeline for Python to build Flask, to package the Flask at the end, well, with some files, with some Python files, package it in the container and push it out to the registry. Run unit tests on the way. There's a linter as well, Pretty much that's it. And the input model is, this is Python, run tests. That's it. That's the model. I don't need anything else. And this is enough to get the full pipeline at the end. And that is the goal. Yeah?
Why do we need the consistency in pipelines?
To never have a surprise that our pipeline broke down. Pipelines must be 100% stable, safe. The least thing you want in your engineering kind of day-to-day life is that you wrote a perfectly good code, but the pipeline broke down. So that's a waste of everyone's time. So once the pipeline is correct, it is saved, it is 100% correct, that's it. That's why consistency. I do not want a slightly different pipeline each time. I don't want that. Okay. Maybe enough?
I think you still have one more question.
Okay, yeah, please.
Have you tried the both ways? Like, I mean, you have the model and you're going to try to generate the pipeline, right? But have you tried the other way? Try to generate the model using image generation, maybe using new LLMs, because recently I tried so hard to generate ER diagram. It's already generated by giving the SQL. No, like
Doesn't work?
Cloud,
It should work.
Correctly.
Okay.
If the table size, if there is 10 plus tables, it's not going to work.
Yeah, but that very much depends on the model. You could take this Mermaid model, which is behind the Mermaid. Is the name also Mermaid? I'm not sure. Also, kind of that one is for diagramming specifically. It should know the ER. But the problem is that the LLM knows what it knows. That is the whole thing. Yeah. All right.
Yeah.
It's late. Thank you.
Thank you very much. And
Oh, we don't have the softballs anymore.
nope, but you get
Finally.
your own present.
Thank
you very much.
Great.
So that concludes it. Thank you very much for everyone that you attended, dedicated time on a busy Tuesday, and I guess also very busy week. So hopefully see you very soon. Follow us on our social media, join Slack channel, and hopefully we'll see you very much soon again. Enjoy your evening.